Hey everybody, my name's Harry. Let me make this full screen. I feel like my YouTube recommendations were on screen there for a minute. Didn't know I was coming to show my soul to all my new friends. Okay, let's talk about codegen. So I'm the CTO at Gadget. Gadget's like a startup in Ottawa. We build a full stack platform for people to build web apps. We're a weird one in that we're both like the framework that you use to build web apps as well as the runtime that web app runs on. But that's the boring stuff. Let's talk about AI. Gadget, I think, is like a weirdly perfect environment for AI to operate in. So the key thing to know about this framework that we do is that it's very imposing. It's like closer to something like a Rails or like a Django, but more opinionated than say like a Next.js or an Express or something like that. It has like very high level primitives that work exactly one way. And if you buy into that, you get a lot of productivity, but a lot of people like don't love it. Or they would do it differently, you know? And when we went to be like, okay, our mission is to make people able to make a bunch more software faster, like we believe software good, more software good, like how can we use AI to further that mission? We kind of saw all the existing tooling doing well at that on what I would call like a small scale. So like Cursor's Command K or GitHub Copilot helps you do like a function at a time or a snippet at a time. Cursor Composer, the new GitHub Copilot workspaces, so on and so forth, that's like a few files at a time or changes to a variety of files. And then like the absolute heroes at Cognition are trying to do like the full-on do anything, touch anything, nutso thing, like, you know, way up here at the slowest execution but sort of most capable system. And so this is sort of where we wanted to play. We didn't want to just rebuild a Copilot. That exists, it works pretty good. And we didn't want to try to take on Devin because we don't have whatever it was, like $2 billion. So here's where we're playing. What that turned into for our plan was app at a time generation. Instead of a snippet or a file or like a series of files, it's go from one prompt to a whole working application. This meets our like business goals in the sense that it's like we want to do something that is flashy. Like we got to get more customers. We want people to like it. It's got to like stick out among all these other things. So that's my selfish reason for doing it. But I think it satisfies the user too. Which is like, I don't know if you've ever gone to start a weekend project or whatever and you've been like, God, just setting up all of these things, just like getting my initial data model into place, just like getting started is so annoying. So it's like the perfect sort of cold start antidote, if you ask me. I'm going to do one real quick in the background so that we can see what comes out the other end. All right. How about build me an app that... Huh? Oh, sure, yeah. Manages the list of speakers for the upcoming meetup I am organizing. Generate app. So this is going to take like 5 or 6 minutes, so we're not going to sit here and watch. I'm going to rant further, and then we're going to come back. Here's my take on codegen soda. Prompt engineering gets you to like 70% accuracy on function at a time or snippet at a time. I don't know if you've used like Cursor in a big code base. It does like fantastically until you get to the really complicated stuff, at which point it starts to fall over. They've done a shit ton of prompt engineering. They know what they're doing. It's like super capable. Their graph rag under the hood's like fantastic. Doesn't really get you all the way there. And what I'm claiming we can do is like worse, right? If you squint, a file is like a series of snippets, but the snippets have to agree, right? Function A that calls function B has to know the right signature of the other ones, right? A whole app is that again. Different interfaces, different imports, different file paths, so on and so forth. And it, like, I don't know if you believe them when they say the 200K token like context window is real, but I don't. I think if you stuff a whole app in there, it doesn't fucking work. So, like just as an example of like why app at a time generation is hard, like I don't know if y'all have experienced this, but if you ask like ChatGPT or Cursor to generate code, it elides it sometimes. It just doesn't give you half of it, right? And it's because the human preference training has made it prefer terseness instead of completeness. And that's because like in a chat setting, that's kind of what you want. But in a codegen setting, you want like generate forever, give me the whole thing. Like I don't want to come back for multiple rounds. So I would accuse the soda codegen of having this problem of too many levers to pull, too many like degrees of freedom leads to too many opportunities for error. And that the name of the game is constrained generation. It's narrowing like the realm of possibilities to be so narrow that instead of like a wide landscape of worlds we could go into, it's a narrow hallway that we like sprint down and we get to where we want to go. And without diving too deep, that's what I just accidentally spent the last 4 years working on. What Gadget is like a superimposing narrow hallway for app development. There's like one way the API works, one database, one runtime, one way to deploy, like one front-end configuration. It's not Webpack and Vite and whatever, it's like one. And so our thesis was we've just narrowed the thing. There's like what a valid Gadget app is so narrow, we can do it, no one else can. So little old Harry, I'm reflecting on him fondly now, went to the archive, was like, what's the best soda codegen algorithm? I'm going to build it this weekend. At the time, there was this thing called LATS. It stands for Language Agent Tree Search. And what it is like Monte Carlo tree search, if you're familiar with that. Basically, treat high-quality generation as a search problem. Don't just like generate once. Don't just prompt once with a chain of thought and like use the output. Generate and then assess the quality of what you generated, and then use that assessment to feed back in and derive new generations. It's kind of like a chess AI, if you've ever been familiar with those. You have like a position, you surmise like what a good move for the next position would be, you assess the quality of that with some heuristics, you like rinse and repeat deeper. Same deal, but applied to like you have a file, you mutate the file, you assess if it's better, you mutate again, you assess if it's better, but you triage it. And so we went and built that. It took a while. Sorry, 1 second. We went off and built this tree search thing, and I can tell you more about the actual like algorithm later. What this is like our internal trace viewer tool that shows kind of like a LATS exploration. So this was me like asking the prototype version of this thing, build me a to-do app. And we start with a node here that you can't see at all. It says score 0. That's our like assessment of the app saying it sucks, it doesn't have anything in it. I hit the next button down here. This is like the 2 in LATS terminology. It's expansions, it's called. And this one got a score of 6. This one got a score of 4. This one added some models. This one, whatever. You like next this. You get this like giant tree that you explored of kind of different apps. What each of these nodes is, which is going to load really slow, is like a whole sub-execution to like generate data models, generate files, generate front-end routes, or whatever. We're able to use that kind of narrow constrained world to say like, you're not generating a TypeScript file, you're generating a Gadget model, or a Gadget front-end route, or a Gadget helper utility doodad thing. And so you can see this is what it did. Again, I won't go into too much detail here, but the gist of it is we spent 2 months on this thing, and we found that as you expanded the tree downwards, the average node score went down. It didn't go up. That each expansion was just another opportunity for the model to make more mistakes. And that there was such still a wide variety of mistakes that it could make that it didn't ever improve. And so I spent like 2 months of my life pulling my hair out trying to make this better and better and better. And I'll just show you an example of like what actually went wrong, just so you can kind of ground it. It wasn't that there was like a main issue or like a thing that we had to overcome. We like added RAG, we like added retries, we added all sorts of stuff. It was just that there was like a litany of too many issues that would crop up at different times. So this is like an example expansion where we had an action on this like task model that implements this to-do app. And the model hallucinated a error class that didn't exist. And it's like the next like expansion would be like, this doesn't exist, like TypeScript error, fix it, and it would fix it. But something else would crop up. In this case, it's like trying to set like tenancy data. It's like a multi-tenant to-do app, and so it's trying to say like this to-do belongs to this user, this to-do belongs to that user, and it like didn't correctly load the user record, like related record, before trying to set it. oopsie daisies, like a mistake a human would make when learning Gadget as well. But the AI just kept making it. So that sucked. That was a big waste of my life. If you ask me, this is like sort of the same thing, though not as cool as the loss function during like LLM training. It's that like you have to get the friggin' error so itty bitty bitty tiny that under repeated invocation it doesn't compound to the point where it matters, right? Like we were doing trees that were, I don't know, 10 deep, 20 deep, and just that compounding error down the tree was like enough to just torpedo the whole approach. So like egg on my face, that sucked. Here's what I think happened. It's that the models can generate any token sequence within their token vocabulary. The set of valid TypeScript programs is like within that. The set of valid gadget apps is smaller within that. The set of correct gadget apps is even smaller within that. And then the set of helpful apps that actually implement what the user's prompt asked to do is like itty bitty tiny. And there was nothing that structurally forced the model into this zone. There was just feedback when it was outside that zone. So what do? We focused on this. Is there a way to generate only correct gadget apps and have the failure mode be a working application that was like outside maybe what they wanted, but still working? And I think just from like a business perspective, that makes so much more sense, right? You're trying out this new product, you saw Harry rant at length about it, like, what does this thing do? And if your first app has a type error in it and like breaks, it's like, boo, you know what I mean? So I think we realized we have like a business requirement around like hard correctness before accuracy or creativity. So my second presentation, not LATS codegen, straight up decision tree. If we could find a way to constrain failure out of existence, we can guarantee that the app will work, it will run, it'll do something useful, it'll serve that starting point, it'll overcome the cold start problem, and we get hopefully our next round of investment, and we get to go hire the team, get the $2 billion, and, you know, compete with Devin. That's my future for sure, definitely. I think like free-form text is the enemy, basically. That there's no, if we want to assume 98% success or higher, we can't let it generate code ever. So what we do is we generate an IR, like an intermediate representation of, we call them duplos internally for lack of a better word, but just like components that pretty much any combination of them is valid, but it's like less expressive than code is fundamentally. And then we like bounce or like write, like we procedurally generate out code from that IR. And the IR, we get to design, right? So we get to kind of pick a design space where we're like, this is allowed to go with that, this can nest in that, this is like, looks an awful lot like a Zod or Pydantic schema that you might pass down to the structured output system, But the nitty-gritty of like the semicolons and the types and the import path agreement, that's handled by this like procedural deterministic layer that we can unit test the living Jesus out of. So we called it internally the grand unified theory of apps. Like me and the other product people locked ourselves in a room for a long time. We came up with like this decision tree of like decide this about an app, decide this about an app, decide this about an app, this implies this implies this, yada, 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 yada. And it produces an application at the end that actually runs and works. Will you give me a time check? Okay, great. Super. I'll tell you a little bit about it then. So given my app from High here, or app for High, if I view the thing, the first thing that the agent does is like synthesize out a sane, kind of unambiguous set of product requirements. If you're into the whole like personifying AI agents thing, this is the product manager's job, is to like, someone gave me this unspecified, poorly documented, perhaps internally inconsistent spec. What are the user stories? Oh, there it's gone. Yeah, we'll get into it in a second. Then we extract the core entities. So this is like, what are in a to-do app, to-do. In a speaker app, it's probably event and speaker, just like the kind of key pieces. Then we ask the system to detail all of those entities, like all their fields, all the relationships, any supporting models, blah, 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 blah. supporting fields like a to-do has a title and a doneness, Boolean, yada, yada, yada. This was, I think, our biggest innovation, is we formalized the notion of life cycle parenthood among models, which is to say, like, if you have an event management system, you have event records, and then you have like speakers who are at those events. If you delete an event, the speaker, or like the record of a speaker speaking at that event, also needs to be deleted, right? It's like the only thing that makes someone speaking at an event is the fact that the event exists. The human still exists, but the like join record is gone. So anyways, we like modeled out an intermediate representation for life cycle ownership. And then we like get into kind of like form layout, which is like if you have a to-do, maybe it's nice to put the Boolean as the first column and the text like of the to-do is the second column in a table, and like, you know, prioritize that. So each of these like little steps becomes like a prompt engineering challenge, an individually evaluatable little subcomponent, like a thing we can swap out and try. We can use different models for different pieces, so on and so forth. And then like after months of stress, we kind of arrived at this approach for each one of these things. So COT here is short for chain of thought. Each like comma or plus here is like another round going back to the agent under the hood. So we do, for most of these things, we do a free-form text, like basically explore the problem, like latent space, get it out of your system, figure it out, sort of analysis. And then we go into like a structured output that produces something that we can assess the quality of like very, very accurately. So in the case of like core entities, it's like every entity must have a name, like it must have a thing we call a grain, which is like what real world object it corresponds to, so on and so forth. And there's only a few kind of valid things for each of those thingies. But we found that if we like launched right into the structured output sort of phase right away, we got much poorer quality output. So a lot of these things are just experimentally determined, like Harry squinting with red eyes very late at night, being like, this sucks, and just making them better over time. And then these validator loops are also like a really powerful thing. When you are defining data models that have relationships among them, like say in a to-do app, maybe we have, or a Kanban app, like a Trello, you have like Kanban categories and then cards that sit in the categories. The relationship between those models, like the notion that a card belongs to a category and a category has many cards, exists in two places, right? You need like a foreign key from the one pointing to the other, then the other kind of has to know that that foreign key exists and like owns it. If you've ever done Rails, you define relationships on both sides, Prisma, same sort of deal. That's a major opportunity for the model to make mistakes, right? It might only make one half of the relationship, or it might create a parent, like a parent has many children relationship that doesn't have a corresponding foreign key coming back. So we're able to, because we've narrowed down the problem and we're not talking in like the full expanse of code, it's a little bit easier to recognize and build like a validator that's like, Mr. Model, you produced an invalid relationship, here's exactly how it's invalid, like go another round, come back. So we figured, I guess, 5 of those out, which are just totally bespoke and different for each little use case, but work really great. So the basic structured outputs, or this thing called BAML, which I'll rant about, gets you the schema, but not the kind of like domain-specific validation. And that's what those allow us to do, which is great. Okay, I have reached the end of the stuff I wanted to say, and I have like a million other tiny things that I just want to share. How much longer would you like me to go?
Want to do Q&A?
Sure, let's do Q&A. So, one thing, the app, it's ready. Witness your future high. Let me just dive in here real quick. So I generated the application. It provisioned a Postgres database, set up a backend runtime, set up a front-end runtime, generated a bunch of example models from those example requirements, set up a bunch of sample data in the application. Oh God, don't break on me now. This is the gadget editor. I don't know why the front end isn't loading here. But it decided to call it Mouthpiece. I don't know why. Oh, look, it's Oh Hi. That's fun. Sad. What's going on here? Oh. Well, okay, I'll show you the code real quick. So these are like the example models that it produced. We said we have a thing called a meetup, a session, a speaker, a talk, an invite. There's going to be relationships set up among those things, right, where a meetup maybe is scheduled, happens more than once. Like a speaker probably has many talks that they give, so on and so forth. And then in the front end here, we like create a bunch of these routes. It's just like a remix app, if you're familiar with remix. And where here, this is like the new form to create a new speaker. And so this is like that procedurally generated code where we kind of develop the IR that's like, you should probably put the first name, last name, and contact email in a row. And we do that, but then we like write out the right kind of React components that do that. And yeah, I have no idea why it's not loading, and I'm sad. It's not released yet. I'm still tinkering, but we're gonna get there soon. Yeah. Okay, that's it. Thanks for listening. I would love to take questions. I know that was an awful lot very fast, and I have much detail to share.
Hi, that was very cool. So it sounds like you have some kind of secret sauce called BAML. So
what is that? That is open source secret sauce. It is this thing. It's a alternative to OpenAI structured outputs or like the LangChain, like Pydantic kind of validation loop. But the gist of it is, well, actually, fuck yeah, I have a slide for this. Right. Who's used OpenAI structured outputs? Who knows what the heck I'm talking about when I say that? Okay. If you want a model to generate JSON, there's like the raw LLM call, there's absolutely nothing that will make it generate JSON, right? It will happily go off the rails every so often. So OpenAI structured outputs is an applied version of what's called constrained decoding, where at each token production of the LLM's kind of generation cycle, there's a running parser that knows like what the next token in a valid JSON output would be. So it's like if you just did a double quote, you can really only do a comma or a close curly next. Or if you just did a comma, you can probably do a double quote to open the next JSON key. And so that narrowing allows the thing to just like not make the dumb mistakes in producing valid JSON. Structured outputs work great until the model degenerates and it refuses to produce that double quote, comma, or open curly. So this is an example from like a real production trace where this is my schema that I was passing to the OpenAI structured outputs thing, and it like did the first sentence right, and then just like produced utter gobbledygook because for whatever reason the close quote or like kind of next token that would have put the parser into the other state never occurred. So what BAML is an answer to that. It's a super duper relaxed JSON parser that doesn't do the constrained decoding thing, but recovers super duper gracefully from many broken versions of JSON. So the model doesn't have to get the commas right, doesn't have to get the curlies right, doesn't even have to get the quotes right. BAML is just this like Rust nerd who like built a parser that overcomes that. So I find it's better than structured outputs in many ways and way worse in a variety of other ways, and I can share more about that.
One more question?
Okay, at one point you mentioned that when you were trying to get JSON outputs directly, they were not as good as when you do COT and then a JSON output. So are you taking the chain of thought and then providing it to create the...
Oh, yeah, absolutely. Like the way I think about it is like how much thinking is necessary for the first tokens at the start of a response really governs the output quality. And so the giant chain of thought at the beginning makes the first bit of the structured output really obvious. Like you could almost use like a dumber model even to do the second round. It's that you kind of have to like resolve all the ambiguities, figure out what it's going to be, like get really close to what you want before you enter the structure phase. And I think it's just because our structures are like big and complicated. Like if it's like a JSON with 2 fields, you don't really need to do it. If it's a giant data model with 19,000 properties and like all of Gadget's stuff, yeah, we needed it.
Thank you.
No problem. Thanks, everybody.